Technology advancements have dramatically revolutionized numerous industries, but the electric system has continued to operate in much the same way as it was in the early 20th century. The aging electric grid infrastructure is inefficient and increasingly unreliable. It's facing limitations in keeping up with the ever-increasing energy demand. Recognizing these challenges, energy communities are combining information technology with the electricity infrastructure to create a smart grid. Smart grid rebuilds the outdated infrastructure, ensuring that power is delivered consistently and the system is managed more efficiently. It also prepares the electric grid to meet increasing demand. Today, we use more electronic devices than ever, and so the demand for electricity is growing so quickly. Without modernized electric grid, the traditional system will be unable to meet the ever-increasing energy demand. Smart grid enables a two-way communication between generators and consumers. This interactive capacity also allows for automation, which becomes especially helpful when service fails or power outages occur. Unlike in the traditional system where a customer had to call utilities about outages, with Smart Grid, utilities will know immediately when issues occur because equipment like smart meters would stop sending sensor data to the facility. All components of the Smart Grid have IP addresses which enable two-way communication, so utilities can manage energy distribution more efficiently and respond to problems faster. The Smart Energy Grid helps utilities to proactively address emergencies before they cause large-scale problems. Smart Grid lowers energy costs. It gives consumers control over their energy bill by enabling them to monitor and adjust their energy use through smart meters and home energy management systems that offer 24/7 rate and usage readings. Consumers can even schedule their most energy-intensive tasks for low-demand periods so they can pay less. Smart Grid reduces costs to energy producers. To meet increasing energy consumption, today's system relies on the building and maintenance of expensive standby power plants which sit idle except during rare critical periods. Smart Grid allows direct communication with end-user equipment to reduce consumption during these peak periods, lowering the need for costly standby power plants. Smart Grid also benefits environment. It increases energy efficiency by enabling consumers to reduce energy usage by making informed decisions. Also, through new technologies better managing electricity supply to bring the supply closer to the consumer, Smart Grid reduces the amount of wasted power from long electricity transmission process. Smart Grid makes renewable power feasible. Sophisticated smart grid systems are needed to strategically manage the diverse renewable power sources like wind farms, solar plants, and hydro stations. Smart Grid will ensure that this energy can be stored safely and distributed where and when it's needed. While a smart grid generates many benefits for energy producers and consumers, it is not free of challenges. First of all, rebuilding the existing electric grid will be extremely time-consuming and expensive. The cost of replacing the current infrastructure is estimated to be somewhere between $13 billion and $50 billion. Another concern is that certain industries may not be able to make the most out of the real-time pricing information offered by smart grid technology. For example, hospitals may not be able to make the most flexible and economic decision in adjusting their energy use to real-time information because they must obey health regulations. As a result, they will be billed more heavily than other institutions. Additionally, installing a smart grid that utilizes the internet to provide real-time data might increase the risk of cyber attacks such as privacy and security breaches. The chief of the NSA confirmed that a couple of foreign countries, including China, are capable of penetrating the U.S. electrical and water infrastructure, which could cause the failure of our systems.
Now I would like to talk about how data flow works in smart grid system. Data input or collecting data from the appliances that are involved in smart grid network is mostly done by SCADA, short for Supervisory Control and Data Acquisition, or smart meters. That is, when you use one of your appliances that is connected to a smart grid system, information of data usage, such as energy consumption or status of the appliances, is acquired by those two components. Communication network gears such as router or Bluetooth converter then receives those data and transfers it to database management system where the data is stored. Then the data is analyzed through analytic procedure using algorithms such as dynamic multi-objective optimization algorithm. Data analysis here means to extract meaningful patterns in energy usage and predict values based on the collected data. After going through analytic procedure, the data goes back to database where it can be then made accessible to users via web-based systems such as internet network on cell phone or PC. Thus, the users are exposed to data outputs such as real-time electricity consumption, consumption forecasts, or optimal electricity costs. In order to make it easier to understand the data flow in smart grid system, here's a real-life example. Let's say it's a hot summer day and you turned on the air conditioner that is connected to the smart grid network. While it's turned on, smart meters collect information such as how long it is turned on, how much electricity it is using, and how your AC is doing. Data flow number 1 illustrates that. Those information input is then transferred by, say, router installed in your household to database. That is flow number 2 and 3. Then, the collected data of your AC is analyzed in analytics center, such as patterns of your AC usage, like when you use your AC more, night versus day, weekend versus weekdays, etc. It can also determine when your AC should be turned on and off based on the status of your AC. That is data flow number 4, and after that, number 5. The analyzed data is then sent back to the database. The analyzed data is then made available to the users through internet on your connected devices such as phone or computer. Web-based technology, thus, visualizes the data output such as patterns in your AC usage, how much electricity bill you'll have to pay in the future, and information about optimal usage of your AC. That is data flow number 6 and 7. So, as a summary, usage information is collected by smart meters. Communication network transfers the info from meters to database where it is stored. Data is analyzed and then sent back to the database. After that, data is sent to a web-based system and is made accessible to the user. Data output is made viewable by the user via internet on cell phone or PC. Despite the numerous advantages, smart grid system resulted in various privacy/security concerns. Most of them have to do with the way smart grid system operates. Because smart grid system involves wide area integration and interconnected networks between appliances and user, the air gaps which ensures that a secure computer network is physically isolated from unsecured network are very likely to be weakened. Without security buffers such as air gaps, smart grid system is made vulnerable to external attacks or intrusions. One can categorize the privacy and security concerns in smart grid system into 3 groups: concerns about confidentiality, concerns about availability, and concerns about integrity. Confidentiality problem refers to exposure of the system's or the user's information to unauthorized access. Availability problem refers to whole or part of the system stops responding to signals from other system components, thus disrupting the data flow in the smart grid system. Integrity problem refers to the destruction of system functionality when data collected from one component of the system is regarded as untrustworthy by other components. One solution that is suggested by Barletta et al. Thus focuses on restricting access to the smart grid network. They suggested using secure multi-party computation method, which is having smart meters that belong to the same group of authentication encrypt their sensitive data using verifiable secret sharing of the keys. This way, only those with passcode can access the data. Therefore, restricting and complicating the access of the unauthorized results in the air gaps to be strengthened and better preservation of personal data.